So now let's understand that what are the matrices inside R. So basically, matrices are the data frame which will contain the list of homogeneous data into the tabular format. So when we create the matrices here, so here we'll be working with the same data type, homogeneous data type. And here we'll be putting that thing into the tabular format. We can do certain arithmetic operations onto the elements of the matrices now, right? So how we can make the matrix here? So one can see here, one has to write the matrix word here. Inside it, we have to put the data, and here we have to give that how many number of rows we need or how many number of columns we needed while creating the matrix now, right? So here, let's make that matrix one by one now. So here one can see matrix is a collection of data elements arranged in two-dimensional rectangular format. Okay, two-dimensional rectangular format. So here first we need to create the vector and then we will form that vector into the matrix format. Suppose here temp is one of the simple vector here. Okay, so here I'm writing the same one. Suppose any value you can write it currently. Okay, here I had just created a simple vector. Let's see the value of vector. Now we are going to create the matrix from this vector. So for creating the matrix matrix matrix, I have to write it here. Okay, this one is coming. This one is the auto response coming here. So this one is the inbuilt because matrix is already into the R as the data structure. So that's why it is appearing currently. Matrix here, and inside the matrix I have to pass the data. So what is the data here? Temp. So temp is holding the vector. So inside the matrix I have to give the vector data, and here I have to give that how many number of row I need it. How many number of row I need it. So here n row is the parameter which I have to settle. So here is suppose here I need 2 rows. So here the data is transformed into the 2 row because here I am having the total number of even data which can be distributed in 2 rows here. So one can see here 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are present. That's why 2 rows are possible here. Row number 1, row number 2. So here 5, 4, 7, 2, 9, 6. Internally it has just made it. So this one becomes the row number 1 and this one becomes the row number 2 because 8 elements are total there. So it is split into 4 into 4. So one can see it here matrix. So whenever you are writing the matrix here, so one has to give here inside the matrix, one has to give the data, this particular data, and then also one has to specify the number of row, how many number of rows. Okay, so in that way. So the total number of elements which you are providing it here, that should be divided into the number of rows, evenly that could be distributed. Now suppose here, I want to see the details of the matrix. So there is an internal help functionality. Help function here. So inside the help, I can just write the details here, matrix. It will give the details of the matrix, that what I can write it here. Just see here. It is just giving matrix base, matrices here. So here it is giving description matrix, create a matrix from the given set of values. So what set of values you have provided? You are providing this temp set of values here into the matrix. Okay, so here you have to provide, you can see the basic syntax of matrix here. This one is the basic syntax here. Matrix, one has to give data here. The data means, suppose I had provided here temp. So temp itself is the data here. Okay, and n number of row, how many number of row you are requiring. So if you are giving 1, 2, 3, so that is based on your data. Even we can settle out the number of columns as well, the way you are requiring the number of columns. So these details are given here. You can take the help also. And here, suppose I'm just writing here. Temp, okay. N row parameter, see here, n row parameter. You're providing 2. And there's another one more, you can see the parameter, you can give data, n row and n column. N column also you can just write it here. So here you can just write n column. Okay, how many columns you need it? So that depends on you. So suppose we are giving 3 for an example. So you can see here how your data is distributed. Okay, see here, 2 row, 3 column. Okay, this one is coming. Right, and if I'm changing it here, 2 row, 4 columns here. Now it is okay. So actually we can see here certain warning is coming. Why the warning is coming? It is saying that here inside this stamp you are having the total number of 8 and you are making the row 2 and 3 columns. So if you are making 2 rows and 3 columns, so here 2 rows will be the 3 columns. So it means 2 into 3. So if you multiply 2 into 3, so total consumption will be 6. Only 6 elements could be utilized. What about the rest 2? So rest 2 will not here. So you can see here 5, 7, 9. So first row, 4 to 6, the second row, first row, second row. And here you can see first column, second column, third column, that one is there. Right? Okay, so this one is there. But where are the 89 and 43? So 89 and 43 is not present here in this way because 2 multiplied by 3 is 6. Only it can accept 6 element, not 8. So to us, that's why warning is coming here. That in matrix, data length is 8. It is saying that total data is 8. And how many you are using? You are using only 6 elements. So where are the rest 2? So when I changed it here, matrix stamp, here I had just given row 2 and n column 4. So one can see here all 8 elements are utilized. 1, 2, 3, 4. Now it is okay. Okay, so whenever we are making the matrix, we have to check it out that how many total number of elements are there. And whenever you are just selecting n row and n column, number of rows and n column, that should be the factor of these total number of elements. Okay, so when I had given here this one 2 rows, 4 column here, then it is agreeable. This is okay. But in this case, 2 into 3 is there. So 2 into 3 is 6. So that's why it is not okay. That's why warning is coming here. Okay, so here we had created it here. We can see here, suppose here this one is given here. M, any two simplified vector one can create it here and one can bind those one here. Just like 4, 5, 6, 7. Suppose this is one of the vector and n is the second type of vector here. See here 2, 3, 4, 5. Suppose this one is there. So here P, I'm assigning to P C bind operation. C bind operation is what? C bind operation is what? C bind operation is column bind. What we can do, we can give here the vectors, M and N vectors here, and we can bind it accordingly to the column. So C bind is an internal operation. So I can use that here. Suppose here I'm just writing here C bind. This one is an internal one. See here, C bind is coming. So here it will be asking what are the values here, M and N here, right? So if I'm writing it here P, so it is there. You can see the columns are binded here. The C bind C. This one, this one, this one, M and N. So values are bind accordingly to the columns here. C bind. So C bind is referring towards the column bind here. It means column bind is there. Bind the columns together. Okay. So in this way, even there is the another operation. There is a R bind. Okay. Instead of column bind, R bind is there. So inside the R bind, suppose here I'm just taking the same statements here. R bind, and here I'm just putting here M and N here. Okay. So I had made it R bind. R bind means row bind. So you can see it is binding the row. Okay. It is taking the two vectors and binding accordingly to the row. So R bind operation. So R stands for the row bind, basically row bind here. So it is binding the M and N, these two vectors here with the row bind, and here it is binding with the column. So column bind is 1 and R bind is 1. Okay, these operations are present here into the matrices. Now suppose here I want to see what are the column names. What are the column names of P? What are the column names of P? So here M and N. M, N is the column names here. Okay. M, N is the column name here. So it is saying column names are M and N. Right. So in this way we can work into the simplified matrices. Right. And now suppose here these two here I'm just taking, see here quad X is one of the vector. One can create it here. I'm just running it here. Click here onto the run button. So it is just running quad X, right? And if I'm clicking here onto the quad Y, these are just the vectors only. One can give any other names as well. So here it is a quad Y. And now here we are binding it with a column bind, both of them here. Okay. So here it is just showing, it is just binding the quad X vector and quad Y with a column bind. You want to see the column names as well. So it will be showing you the column names. So column names are the quad X and quad Y. These are just the column name. One can put any other column name as well. Okay, so in this way we can create the matrices. So these are very simple steps of creating the matrices. Now here suppose you want to do the you want to do the indexing here. Okay, so one can see I'm just clearing the console here. I'm coming here. So what is the com here? Let's see here, this one, this matrices here. It is showing this data. Now here suppose I want to run com 2 1. So here if I want to do this particular indexing I want to do with the matrices as well. Suppose 2, 1. 2, 1 is what? See here, just a moment, wait. Basically, you can see the indexing coming here 1, 2, 3, 4. And this one again specify with the 1 and 2. So if you are looking for the 2 comma 1 here, 2 comma 1. So what is this? 2 comma 1 is what? The second row and the second row and the first column. So the second row and the first column. That's why 24.3 is coming here. Suppose here I'm writing show me 3 comma 2 here. Okay. So here it is showing me product 6.7 here. So one can see here 6.7 here. Why it is showing you? Because 3 row second column. So I told you third row, see third row and second column, first column, second column. So this one is coming there. Third row, this is the third row and second column. So what is the value coming here? 6.7. That's why it is there. So one is doing the indexing in it. So we had learned how to work with a matrix.